Hello and welcome to another IB Mathematics video. And this one is going to be about probability, and it's the last one we have on probability, unless you're doing high level. And what we're going to be looking at is how you actually calculate the probability of an event. You remember that we had the probability of something happening and the probability of something else happening, and they could be dependent. They could depend one on the other. So when we get them combined, how do we calculate that? So, for example, a very visual one, which I particularly like, is the probability of it being cloudy and the probability of rain. Obviously, if when you wake up in the morning, you look outside of your window and you don't see any clouds, you're not going to take your umbrella with you. You don't think it's going to rain. Whereas if you wake up and you see that it's cloudy, some nasty black clouds are up in the sky, the chances that it's going to rain, you're going to think, well, the chances are higher. But imagine that we actually want to calculate the exact probability of that. And we figure out several probabilities. We start counting several cases, and we come up with actual probabilities. So we could have the probability that it's cloudy and the probability that it's not cloudy. Once we know it's cloudy, the probability that it rains and the probability that it doesn't rain. Much more likely than it rains when it's cloudy. And when it's not cloudy, the probability that it rains is very low, 0.05, that's a 5% probability. And 0.95% that it does not rain. Of course, these two together are going to add up to 1, because either it's cloudy or it's not cloudy. These two together are going to add up to 1, either it rains or it doesn't rain, and these two together are going to add up to 1, either it rains or it doesn't rain. So, here's a very important concept. What we calculate here is the probability that it rains and it's cloudy. So, when we do that, we're going to be calculating the probability that it rains and it's cloudy, the probability that it doesn't rain and it's cloudy, the probability that it rains and it's not cloudy or there's clear skies, and the probability that it doesn't rain and there's clear skies. There's a mistake here, excuse me. And it's not cloudy. So to do that, the only thing we do is we multiply this number by this number. That's what we do to calculate the intersection. And it's going to give us 0.6, 0.15, 0.0125, 0.2375. And if we add all of these together, guess what we're going to get? We're going to get 1. So this is how you build a tree diagram. You come up with the different options that you have. And once you get to a particular point, you develop the other options and you write down the probabilities for it. And then at the end, you can calculate the intersections. And that's what's going to give you the useful final intersection probability. But so we have the probability that it's cloudy, and the probability we've calculated, the probability that it rains and it's cloudy. But how do we call these ones here? What are these then exactly? How do we write this in this kind of notation? We want to write something for this number in this type of notation. Well, this is how you do it. And this is something that students often get confused with. All this means is the probability it rains when we know it's cloudy. So the one that we know is the one on the right. And the one that we're going to show is the one on the left. So this is the probability that it rains when we know it's cloudy. This is the probability it doesn't rain when we know it's cloudy. So this is this one here. The probability it rains when we know it's not cloudy. This one here, etc., etc. So this is how it works. We have the probability of cloudy here, probability that it rains when it's cloudy here, and the intersection here, the probability that it rains and it's cloudy. Realize the difference. So this is how we calculated this one, by multiplying this one times this one. So this formula, which might not seem so mind-blowing right now, we can move it around and we can shuffle it around, and this is how we come up with this. And what actually happens, which is the step that you take from this formula you go to this one, and the step to go to this one, the only thing you've done is that you switch this 2 around, and it results in switching this one around. So we can calculate, and this is the important part, the probability that it's cloudy when we know it rains. And this is an important part of probability, and that's the part that you're going to get pretty much for certain question in your exam about. So just remember these 3 formulas. That really is all you're going to need. And once you remember these 3 formulas, plus the other ones that we've seen in the previous presentation, you should be able to solve most probability cases. And here I have a few examples of how to do them. And you should take a look at them. In reality, at the end, the important thing is to be very careful to figure out exactly what they're asking you. And this one is, what are the chances that I'll be having coffee when not having a steak? So I make my diagram here, and I have to figure out the chances that I'll be having coffee when not having a steak. So I need to figure out this one. But to calculate that one, I'm going to be needing other values. So I'm going to get to this point, I'm going to have to figure out other probabilities along the way, and then I'll be able to use these formulas to solve for this. This is a similar exercise in which we're going to be using one of the formulas that we saw earlier on. It's a bit harder, and this is an interesting one because it's calculated out of real statistical data. So, I think it's interesting. And here's one that's a very tricky one, a very typical exam exercise to get you confused. So it can be formulated in a series of ways. The most common one is that you have a bag full of balls, and you take, they tell you the bag has, in this example, 12 red balls and 5 green balls. So they first ask you what's the probability of taking a red ball out, and that's very easy to calculate. What is the probability of taking 2 red balls out? And here's where the trick comes. Once you have taken 1 ball out, you're going to have a different number of balls inside. So keep in mind, this is going to change the probability. And that's just something I put this example here so that you're aware that this type of exercise is very common. So it's a way in which the IB wants you to be alert while you're solving an exercise and be thinking of what you're doing. If you just apply the procedure without thinking of what you're doing, you're bound to make a mistake here. And finally, I just want to point out a little summary of the equations. This is extracted from your formula booklet. We've taken a good look at this one. We've taken a good look at this one. This one we've already seen. This one you have the union, and you have to add them together and subtract the intersection and remember the Venn diagrams. This one here is when you have 2 events that are mutually exclusive, that the union of them, that there's no intersection of them, because this is 0. And if there's and this is for independent events. Remember about dependent events and independent events. So when you can think about this, that since the probability, if they're independent, the probability of B happening when we know A is happening is the same as the probability of B, because if A happens, it does not affect the probability of B happening. They are independent. Therefore, this happens. So we can just extract this formula out of this one here. Once we know it's independent, the only thing you have to remember is that the probability of B happening is the same as the probability of B happening when we know A is happening. So with these equations, you're going to have them available in your exam, and just remember that most of the problems it can be easily solved by plugging the data you get inside these equations, but you have to really figure out exactly what is it they're asking, what information they want you to give back, because that's what's not so clear, and you really have to think about it, whether they're asking me for PBA, or they're asking me for the union, or they're asking for the intersection, and that's the difficult part. So it's a matter of reading the problems carefully and coming up with the right notation and figuring out exactly what you need to calculate. So that's all you're going to need for probability. And I think that now is a good time to move on with the statistics.